Hello everybody, my name is Kayla Rundle and welcome back to my YouTube channel. Today I will be showing you guys the process on how to balance my crankshaft. And to start off, if you do not know what a crankshaft is, it is the biggest and heaviest part of your motor. So the crankshaft is located on the bottom end of your motor. What a crankshaft does is that it is connected to the connecting rods and into the pistons, which is what I showed you guys in the last video when I was assembling those. The connecting rod is the part that looks like a rod. It's connected to the crankshaft, and the crankshaft spins in a vertical movement, and it converts those vertical movements into horizontal movements, which is pushing the connecting rods into the pistons. And to better understand this, basically your engine needs a crankshaft. And even all the way back in history, all engines have always used a crankshaft. This is something that has really never changed over time. And back in the day when they hand cranked engines in the front of their car, if you guys are familiar with this, that hand cranking motion is actually the motion of turning over the crankshaft, which in turn starts the movement of all the internals inside your motor. So now that you know that the crankshaft is one of the most vital parts of the engine to even get everything turning and working, it is also important to balance the crankshaft. It does help maximize performance and the longevity of your engine, and we want the crankshaft to be balanced and to turn as smoothly as possible so you have very minimal issues down the road. In this video, I am at Kuntz & Company, which is a part of GPI where my car is being built. So GPI does offer the machining service through Kuntz & Company. Kuntz & Company does offer cylinder head service, blocks, pistons, crankshaft, assembly, and camshaft service. So many options. Literally can do everything for your guys' car if you guys are interested in this. If you guys even just want your crankshaft balanced and you just need that service alone, they do offer that at the Kuntz & Company. So I will have all that information in the link down below. But let's get to this video. I'm going to leave all the other info about balancing the crankshaft to the professionals and enjoy the process. I think this took us like 5 hours, so enjoy.
So this is our CWT multi-valve 5500 crank balancer. And so basically what this is designed to do is we put on what we call bob weights. And what a bob weight is a simulation of your rotating assembly. And we clamp these bob weights to your crankshaft and we simulate what your crankshaft's going to do when it's inside the motor running dynamically. Think of it like when you get your tires balanced, they spin it up, it'll tell you where to clamp on the weight. In this case, what we'll typically do is we'll drill a hole somewhere in here in the counterweight. This crankshaft's already been rough balanced from Cali's, and you can see where for their rough balance, you had to install a piece of heavy metal. So we went through and weighed up all your components, your bearing, your connector rod, your piston, your wrist pin, your piston rings, all that. Example, like if we're doing something boosted for like a street strip application, that bob weight would be about 100 grams heavier, so somewhere in the mid to high 1800s. And that's just the mass of the components. And if we're going for like a super high-end drag race, that number may be in the low 1500s even.
So which way do you want it balanced? Like just the whole thing like
that's
this
actually
way balanced?
something very important to know that this machine can do that others can't. And these stanchion towers, we have some little vibration sensors. And basically, think of it as like a little hammer hitting on this, and that's what the machine perceives as imbalance. So wherever that force of energy is, or where the imbalance is, they'll basically tap on this as imbalance. So this thing actually measures in what they call the third vector. So think of like XYZ in the grid system.
Right.
So we're reading imbalance this way, and this way.
Yeah.
And we're able to achieve that because in this machine, we've told it what the weight of each piston and each rod is. And so it will tell us where to put what rod in respect to the crankshaft. We'll spin this up to 600 RPM.
Only 600?
Yeah, only. What's crazy is how fast it looks at 600. Imagine that doing 7,200 RPM.
Yeah, at least.
It's going to take its amount of data that it wants to receive, and then it will stop it for us. This is a crankshaft that is meant for like some heavy-duty boost stuff because we're having to remove quite a bit of material. So when they balance this stuff, they're just balancing it in the rough ballpark of what most customers want to run. And with the snatch aspirated stuff,
A little different.
yeah, it weighs less. You don't need a very heavy piston to handle the job. And we're going to be drilling. We'll just save the first spin and then we compare it to the last. See
The difference.
yeah, the difference. Basically, I'm just going to take this very small little mark. I know I'm going to have to drill on both of these counterweights to remove the material that's needed. What's crazy is the balancer that we have. It's like legit the best one in the world. Like F1 teams use this.
Really?
This is like seriously the best machine we can get right now.
I mean, it looks super nice.
Yeah.
Just like the finishing on it.
It's wanting us to remove 130 grams. We're going to use a 5/8 drill bit. It's genuinely off the chart.
Jeez.
So we're going to have to drill multiple bits.
I was like, maybe just add weight to the other side.
No,
That'd be good.
well, here's the thing. It wants us to remove here. So what you do to balance out is you can rotate the 180 to kind of see what that means. Just add weight on the other side. So we'll move 180 degrees out. Then that would mean we're adding material and dead space. There's nothing there.
Right.
So it is what it is. So.
All right, so we are currently balancing my crankshaft. So this is a Callie's Comstar 4-inch stroke. So these are weighted before you buy them. They weigh them at Callie's, and now we get to balance it for my application. Right? Doesn't it have to be a different balance for being NA versus boosted? Like a different weight?
It will. Basically, what we go off with that is like a tolerance. There's folklore out in the industry that different applications require a different type of balance. We've seen no actual real world
Difference.
results to say different.
Right. So as long as it's balanced on every axis, then it's usually fine within the motor. And if you didn't balance it, it would just shake, ruin your crank seal, ruin everything.
Here, when we say like it'll ruin everything,
Yeah.
I'll show you how bad it is right now.
All right, perfect.
Yeah.
I mean, I can imagine people building engines don't always balance it.
As bad out as this is, if it wasn't balanced, it'd be
Really bad.
Yeah. Basically, I just need to go ahead and preliminarily mark where we are going to drill, so that way, when I move this, I'm going back exactly where I want to be. Right here, this is usually when I hit this button, I'll be printing out the progress report, the report card for the final result of the balance. You can see final spin, there's nothing because we haven't achieved final spin yet. Yeah. Our initial spin, you can see right here, an ounce-inch. And what that means is, right here, there's a certain amount of inches from center of this to the outside of this. At this angle, or at this radius from center here, we're 15.6 ounce inches on the left, which is the rear of the crankshaft. We're 16.15 ounce inches off on the front of the crankshaft. That sounds like a bunch of crazy talk, right? Yeah. So let me break it down, right? I mentioned earlier that balance is perceived by like a little hammer tapping in the engine block, like messing up the mantra of what's going on.
Yeah.
Let's take 7,000 RPM. 7,000 RPM, there's a hammer hitting at 116 times per second with a force of 1,360 inch-pounds. That's a big hit.
Yeah.
And that's very fast, a big hit. On the front side, that same 7,000 RPM, you're over 1,400 inch-pounds. So when we talk about out of balance and the force, and you were mentioning how it's going to run rough. I mean, this is, you can imagine that this crankshaft will be spinning inside the engine doing this because it's so imbalanced. And it's doing that at thousands of RPM per minute. So we're going to correct that. And then we'll get these numbers here to about 0.2, 0.3 ounce inch is where we'll end up at. So a lot less.
Yeah, way less.
Yeah, is it not good to go up and down, because that's what I'm taught to do. It's just
on
keep releasing all the metals.
Yeah, here's the thing.
So I'm so used to like one pull and then release it all. One pull.
You're trying to go one nice easy pull. What happens on these hardened metals when you drill them? When you let go, you're allowing the room temperature air to get to it, and it'll harden. that little, and the longer you let it sit out in the open, the air will cool off the surface and it'll actually start to reharden again. So that's why we use plenty of the cutting fluid, and you try and keep it as one slow, easy pace as possible.
Yeah. Okay. Cranker on.
And that you gotta turn it the other way.
It's going slow. You sure this slow? Do we put more lube in it yet?
It's actually when it's making that nice chip like that, or that nice real long curlicue, that means you have the RPM and the pressure about right.
God, so I'm just a pro.
Yeah, you're natural. A+.
Look at that thing.
Badass. No, this one won't be that hot.
Oh yeah, look at
That's
that
one you did.
noodle. Pro at work. That means I did a good job, right?
Yeah, it does.
Consistent.
I'm gonna spin this up to 600, and it'll start analyzing what it wants.
Decent?
Decent. So basically what we did is, with this, you never want to take the full bite out all at once. You kind of want to ease into it. But we went from 126 down to 45 grams. So basically, the reason I did these holes in this pattern is so, yeah, I can go back in these holes and I can just kind of tune in on it to be able to get that balance out. Because if you would have went for the whole enchilada right when it said, we could have went over, and then we would have been at a point where we would had to add heavy metal.
Yeah.
And it's just a big mess.
Not good.
Yeah. So on this side, we're now 45, and it wants 34. Right here. So you can see this is the middle hole that was originally. And you can see it's kind of moved in between the two. So now we can remove those 34 grams by just drilling a little bit more in either one of these holes.
Sweet.
More drilling.
Woo!
Yeah.
I've been hard at work trying to get these numbers as close to possible to 0. And the way you described it is that factory cars are usually around like 1, and then performance cars are around 0.5. And then like F1 cars are like what, 0.1?
Yeah, like 0.1
or
yeah,
0.05,
something like that.
And so far, he got us down to on the left side. Is that what you call it?
Yeah, the left side we got it
To
0.2.
0.219,
Yeah.
and then 0.456.
A little bit more work.
A little bit more, just to balance out the right side to the left. It's impressive. I thought he was gonna give up at 0.6, but yeah, they just keep going and make it more perfect.
On this, like when you get to balancing, you'll cross a certain threshold, and like you remove a metal, and
it'll spike, and then you have to drill.
and then you have to add. You'll cross the threshold,
no.
and honestly, the 0.2 on either side, that is
0.2 is really impressive.
Yeah, it's more than good.
Got it down perfect.
Yeah.
And this whole process again is to basically not cause damage in the engine over time. Like when you get to higher RPMs, it like moves more correctly.
Yeah, exactly. So what we'll do is we'll save the last spin since we're done now.
You'll see the difference.
And we'll hit save, and we'll look at this print sheet. So we'll look at the forces at like that same 7,000 number earlier. So at a frequency of 116 hertz, the force of imbalance was equivalent to like a hammer hitting at 1,350 inch-pounds on the left-hand side. So now we go down to where we just finished up. The same 7,000 RPM that has dramatically decreased to 25 inch-pounds.
Very impressive. Like trying to explain this as best as I can, trying to get on footage. He's been at it for hours, trying to get this crankshaft
I don't know how
perfect.
many hours I've been on this.
He's been on it for hours. I think I've been sitting here talking for at least 2 since everyone left, maybe.
Yeah, everyone left at 4:30, so
Yeah, and we're
I don't know, it was like 6:30. Yeah, 6:30.
6:30.
We've been at this for 2 hours.
Yeah, 2 hours since everyone left. That's what I figured. So
Yeah.
puts in a lot of work.
We're
I
done.
think Aaron's coming and he's probably like, "Are these boys done yet? We just finished."
Perfect time.
We got the crankshaft all balanced after a few hours of work. at the Kunz & Company. We transferred the crankshaft here. I'm back at GPI and we're about to put the crankshaft into my new motor. I wanted to show you guys the end results of the crankshaft before we tuck it away for hopefully a while. Here we drilled 3 holes on this side and you can see where it's shaved down just to take away that little bit of extra weight. That's because the manufacturer puts these added metals in here, which are very, very heavy compared to the metal here. And so this is all ready to go. We just have to clean it up and throw it in the block. Stay tuned in the future for that content. I'm really excited to get this thing together. We are only 3 weeks away from LS Fest East, so I'm just now putting together my block and we have 3 weeks to go to get the whole car finished and to LS Fest. Again, I'm gonna be at LS Fest East at the Holley Performance booth with my car with the build finished. Hopefully I will see some of you guys there. Don't be afraid to come up and say hi to me. Well, I hope you guys enjoy this process. I don't see much content on balancing a crankshaft whatsoever. Having a machine shop in general is very rare, so I will also have the Kunz & Company and GPI information in the description of this video if you guys need to get your crankshaft balanced for a 416, 427, whatever you need in whatever build, they do it all. But I hope you guys enjoy this video and I hope you guys have an amazing day or night, whatever time it is, and I will see you guys in the next one. Peace.